Okay, this will be a little bit easier, I think, to see because now we're dealing with some actual functions. But what if we have a circular cross section? What if we take some graph, some random graph, and we rotate it around the x-axis? So what we're going to do is we're going to take our x and y axis, we're going to give it some curvy thing, and then we rotate the curvy thing around the x-axis. And what it does is it will actually give us a three-dimensional shape with volume. And if we pick some point on the curve, it's going to rotate all the way around and make a circle. So if we need area times the height, okay, we're going to still stick with that whole area times the height. So we're still sticking with this guy right here. How do you find the area of a circle? And the area of a circle is equal to pi r squared. And when you're dealing with volume and you're dealing with all kinds of cool functions, the radius is the distance from the x-axis or the point of rotation to your curve. That's your r value. So whatever our function is will be equal to our r in most cases. Now, if you rotate around a specific line or something else, we'll have to do a little bit more math. But if we rotate around the x-axis, our function is our radius. So we would look at the function squared, which is this part, times pi. And then for the volume, we would add times the dx. Remember, if we were to look at this from the side, straight on from the side, and we've got this fun shape here, if I integrate from here to here, and I want the volume, then I add up this volume plus this volume plus this volume plus this volume, and that's where the dx comes to play. It takes care of the height. And if I add that enough, I can get to my the volume of my shape. All right. So I'm going to delete these guys real quick, and then we're going to look at our problem. All right, so what I've got is the region between the graph of f of x equals 2 plus x cosine x and the x-axis over the interval -2 to 2. And this is going to be kind of fun. If we do this by hand, we're going to have to use integration by parts because there's no way to handle x cosine x. If you're one of my kids, and the way I'm going to solve it on this particular video is I'm going to use my calculator. So what we've got is this graph. Hold on one second. Brilliant idea to add our graph. So here it is. We want to find the volume of the solid from 2 to 2, from -2 to 2. So we start here at -2. We go over here to +2. And we rotate this around the x-axis. So, you know, if we rotate the shape around the x-axis, we'll get a shape that looks kind of like a vase. So if you can imagine this guy, you know, doing something along the lines of, and I'll try and sketch it out really well, something along the lines of this. Okay. And notice we would integrate all the way down to these places. And so we're going to get a circle shape. We're going to get a circle shape right here. We're going to get a circle shape right here. Okay. And so what's the area of this circle? The area of this circle is this guy right there, 2 plus x cosine x. So the integral on this particular one, and they give us the setup, goes from -2 to 2, and it's going to be pi times the whole thing, right, times 2 plus x cosine x squared, because that's the radius, dx. Okay. Punch this into your calculator now. It's really easy to do. It's not hard. And when you do that, when you punch it in, I get 52.43 units cubed. Now, make sure that on your calculator for your mode that you are in radian mode. If you're in degree mode, then this will come up with a really wacky, weird number. Okay. So don't let this be hard. Anytime you rotate something around a fixed point, something around that fixed point, you get a circle every time. And so the area of the circle is pi r squared. The function is the radius in this case, and life is nice, okay? And we're going to pause it here before we look at the bottom equation because this guy is actually going to involve a washer. So hold on, we'll see what it looks like.